Welcome to the last part of this foot on wheels problem in this recitation of optimization using spreadsheets in advanced network design. This is a very short problem statement, so hopefully you read through it before joining us. If you haven't yet, please pause the video. If you already went through the problem statement, you now know that we want to ensure a level of service policy that says that 75% of the demand at least should be served in less than 7 minutes. This is only applying for the hubs to the city areas, so keep that in mind. We're only adding this constraint for a portion of our network, so that's very interesting. And we're still aiming to minimize the total delivery time while complying with this new level of service policy. By now, you probably noticed we're still using the same model we created for part 3 of this problem, but we're adding the level of service constraint. So finally, we're using all possible elements we presented you here. Go ahead, click submit. If you still have any questions, please click the show answer button or use the discussion forum for further support on the model formulation. I encourage you to once again see if you need to adjust or fix anything on your model, and meet me in a few minutes to work together into adjusting our model in the spreadsheet so to solve this last part of the problem. Last time we're going to do this in this recitation. I'm going to duplicate part 3, move it to the end, rename it part 4. So there are only a couple of elements we need to bring from our problem statement. One of that is that the level of service policy is 75% of the total demand. This is a minor detail, but I think it's hugely critical to the model. We could have told you that it's 75% of each one of the area's demand. We could have mentioned that it's a certain number of units out of each area demand. But we're talking about the total demand. We're not giving you a detail per area. We're not talking about each one of the demands. So even though it's a very simple data point, always go through the problem statement, allocating some good time to that. I know that when you are stressed out with a graded assignment, an exam, or anything that is timed, you sometimes just go quickly through the problem statement and jump into the spreadsheet. But making a mistake could cost you a lot of time if you didn't read through a simple detail like this one. This is actually 75% of all. Is it at least? Or is it less than? Because that's different also. If it's at least, it is 75% or more. If it's less than, is up to 74.999. If it's equal to, that's also different. So that's a single word in the problem statement. And if you miss it, then you're probably taking some time afterwards into correcting if you notice, or you just make a mistake. And it's just because you missed a minor detail, but still critical in the wording of the problem statement. In this case, as I said, level of service policies is at least 75% of the total demand. I'm going to write that here, not to forget, at least that. And with that, I'm ready to go to maximize the view of my spreadsheet and start working on adjusting our model together. The first thing I need to do is identify whether a hub and an area are connected within less than 7 minutes. To do so, I will create a new table, and I can just add it here. Here. And this is going to be all made out of calculated fields for me. And what I'm going to use is an if formula that says if this is less than 7, which is what I'm asking, right? Is less than 7 minutes, please make it a 1. So that means yes for me in binary, or otherwise make it a 0. Okay? So let's first know where is it that my distance in minutes is measured in less than 7 minutes. As you can see here, just to confirm if this is working properly, I have a 1 in between half 2 and area 2. That means that should be less than 7 minutes. If I go to the other table and check, that's 4, which is perfect. Just checking half 1 to area 2, you can see this is a 7. But I'm being told that it's less than 7, so 7 is not coming into the equation, and that's not making it a 1. So that's a no, this is not complying with the level of service policy in terms of distance in minutes, right? Why did I create this table? Because I want to know of all those units flowing in my variables, which one of those are actually complying the level of service policy. So I'm going to create another table here. And yes, I know it's a lot of changes for a very simple problem statement, additional information. But trust me, it's not that complicated. It's just about understanding what is this doing and why. In this case, what I'm going to say it's, okay, of all those units flowing, which ones are complying with the level of service constraint? To do so, I will just simply multiply the flow between those areas times the fact that this is compliant or not. If a certain flow from a hub to an area takes longer than 7 minutes, this is going to give me a 0 back because I'm multiplying a flow times 0, okay? If a flow between a hub and an area is within 7 minutes, it will just bring me the flow in units, that would be in boxes per day. Why is that? Because that's the unit of my flow. I'm flowing boxes from hubs to areas. I'm just multiplying it by 1 if it's complying the policy. So you can see this here. I will just copy paste my formulas. And now you can see that, for example, hub 1 to area 5 has 50 units flowing, and that's the only flow from hub 1, just going out from hub 1, that complies with the less than 7 minute. If I go to check the minutes between hub 1 and all the areas, I can definitely confirm that that's the only one that's complying with the level of service policy. So that means that the outcomes of my calculations in these tables are correct. Let me name the tables. So I would say hubs to areas below 7 minutes distance, so that we keep that information handy. And then the next one will be demand with complying with the level of service policy. Actually, it's demand satisfied, complying with the policy. Okay, hope that makes sense. So I have a couple of ways to go here. As I'm being told that I need to comply with the percentage, I'm going to calculate that. So the first thing is saying, okay, what's the demand fulfilled within that level of service policy? So actual demand within the level of service policy. And I'm going to just sum all the units as I just said. So 252 units. I want to know how much that represents out of the total demand, right? So I would say just make this into percentages. This would be boxes. But let's do it as a percentage. This would be the actual demand fulfilled divided by the sum of all demand. And that would be 63%. What is this telling me? This means that even though we already found an optimum result, meaning that I'm renting hub 5 and that this is going to give me a total number of minutes that it's a minimum possible to achieve in such network, this is not complying with my new level of service policy, because only 63% of my demand is being fulfilled within less than 7 minutes, considering the capacity available and the hubs I'm using. Now that I have all the information I need, I'm going to set up my solver so that I force the model to comply with the 75%. So I'm going to use data and solver. The constraints have not changed. Remember that the variables are still the same. I have not changed anything on that. The objective function has also not changed, so I don't need to adjust anything. The only thing I need to add is that I want this 63% to be at least 75, which means larger or equal to it. Okay, so I will just click OK, I will click solve, and I will analyze my results. You can see here that I'm still running hub 5 and only one of them, but now I'm fulfilling 75% of the demand within the level of service policy. In the next video, we're going to analyze the results. In the meantime, I invite you to populate your answer and meet me in the next video to talk a little bit about the insights obtained after we analyze all this and summarize all the recommendations we talk about when it comes to acing exams and graded assignments. Congrats on making it here, and see you in the next and final video of this recitation.